Okay. So for today's presentation, we will be showing a Java client connecting to our Fabric network. We are using the widely used version 11 of Java. And in this example project, we are using the Gradle. It's becoming more popular now. Before, most of the Java clients are using the Maven. But today, we're using the Gradle to actually set up our dependency. Very simple. We're using the OK HTTP to communicate with our API. And then for JSON processing, is we are using the Google uh, JSON client as well. And
Okay.
so this presentation has several steps to demonstrate the different functionality of our API. Let me show you. So if you look at the source code at the moment, first, it will initiate an authentication. That means it will first get a token to our API before it can proceed with performing transactions.
Okay.
So once it performs the authentication, then it will save a order, or shall we say a coupon into the system. So first it will create a save order transaction.
Okay.
And we have the basic structure. Let me show you the transaction first. So this is a sample. We have the order date time. We also have the settlement number as well as the confirmation number. Now, after it performs the save, it goes to the next step, which is to query the settlement, which means it will try to query the order by settlement number, just to demonstrate that after we save, we should be able to retrieve the order accordingly. And then we also try to retrieve. This is actually in sequence. So first authenticate, save, query by settlement number, and then query all the orders. And then that will be the end of the step, basic transaction. So it's the complete workflow from authentication, retrieving the token, to performing transaction, and then to querying the transaction. In this example, it will be sequential, meaning one step at a time, and we will be showing, we don't have any front end, so everything will be presented in the console. Okay, so this is
Okay.
the source code. Now we will try to demonstrate. So I have here the Java client. So just to make sure that we are ready to run, we will perform the build using the Gradle build system. Okay, so it's very successful. Now we are ready to run. On the other hand, I also have our API, which is actually ready now to accept any request, which is our Fabric API. So let me
Mm-hmm.
demonstrate, just to emphasize that at this point, I am showing a very simple Fabric network. Let me show first. Our public network is one server, very low spec server, just to demonstrate. This is a 2 gig of RAM with two virtual CPU, and
Mm-hmm.
it's running only one committing peer, one CA, and one orderer. That's why you can see it from here.
Okay.
Okay, just one single CA, one single orderer, and one single peer. And there's one more, which is our state database is also running, which is the CouchDB for peer number one. So
Okay.
basically, once you run a peer, you have several options. You could use the level DB, or you can use the CouchDB. In this example, we can assign. One of the advantage of uh, the Hyperledger Fabric is it's very pluggable. It allows you to customize whether to use different consensus or you want to use a different state database. But for today's presentation, we are using the CouchDB as our state database. At the same time, I'm also showing to you is we are because everything in Fabric is based on the Docker container. That's why I can show you that we have our smart contract here running on being installed on the channel, and it's called the payment. Here, this one, payment. This is our payment smart contract already deployed. Okay, so I'm just showing you how the basic network set up for the Fabric. Again, just to emphasize, this is not a high performance setup, because normally, if you want to achieve a high TPS, like 1000 TPS per second, you will deploy it in a cluster, meaning you have multiple orderer that can process simultaneous orders. You have multiple peers that can process also and commit transaction. But anyway, this is only for presentation purpose. So we are using one single machine and one single orderer and one single peer, just to demonstrate the capability. Okay. So
Okay.
I will run now. I will run the client, and I will show you the client executing and communicating with our Fabric API. At the same time, I will also show the API accepting the request from the Java client. So we will run. Okay. Okay. So it's done very, very fast. Let me show you first. First, it performs the authentication. This is the Java side. And also you can see from here that it has accepted the authentication here.
Okay.
Okay. Now on the second step is it try to save the order with the settlement number 1000 unsuccessfully with this particular settlement number ending in 241, successful also. And we can verify that in the API. Here it has the save order with 241. Here is the settlement number. So at the same time, we also query the settlement number. By the way, if you will notice, Babisan, when we perform the query, it has so many data, because this already contains the remember, you have the Excel file you sent to me with the sample data. It's
Right.
actually stored, but it's still very fast to query even with this much data. Okay, that's why you can see from here. That's why all the functions are completed, and it's very fast to actually query and receive the confirmation number. And also, it was able to query the order by settlement number. You can see it from here. It's a 241, meaning after saving the order, it will try to query the same order number by settlement number. So it's also executing successfully. And also here, it is executing also from here.
You mean this is the 1,000 of the transactions?
Yes. No, one single transaction, but I was able to save. But don't worry, I will also demonstrate to you how to save 1,000 transaction.
Oh, okay.
Okay, but just to demonstrate first that this is executing multiple different transactions. First, it tries to authenticate, save the order, and then at the same time, query by settlement number, as you have requested, and also query all the orders. I have already pre-saved the 1,000, but I will also demonstrate to you at the same time.
Okay.
Okay. So that's why you can see here, we have the receipt number or the record number. It's already completed. Now again, let me clear this one. Let me show you the source code again. In the source code, in this example, I have loaded the the data from a single file. That's why you can see here, it's a JSON file, single.json. And what does the single.json contains? It's just one single data as an example, just to demonstrate.
Okay.
Now, I have another one. We call it the data.json here.
Okay.
And this one has so many data.
All right.
This is also another set of 1,000.
Oh, it's up to 1,000.
The same record as in the Excel file. That's why you can notice it's a 1001, 002, 003, and so on.
Yeah.
Just like in your Excel file.
Okay.
Now in our source code, we changed. Now remember, we have the single and the data.json. Now we change to the data.json. Okay, and then we will go to the Java to execute. So just want to confirm it's now data.json here, which the data.json is this data file.
Okay.
So the Excel file that you have sent to me, I quickly converted into the JSON file, so it's much easier to read by batch.
Okay.
Okay, now let me run and execute the functions. So again, we will execute. You can see now it's saving the record. Now take note, you can see here executing, and there is also the time. And I will explain to you why. Okay, so it's done. Total execution time is 33 seconds on the Java side.
Okay.
Question, can we able to achieve a faster transaction per second, Barizan? The answer is yes. The answer is yes, but not in this kind of setup. The setup is we will use the cluster, meaning number one, in a cluster mode, not only we use cluster, because even if you use cluster, but you only have, like, for example, one orderer, one committing peer, it also doesn't work. It has to be multiple orderers that can process transaction at the same time. Also multiple peers for committing. Not only you cluster the API, the fabric, you need to also make a cluster for your API. Remember, that API is the entry point, right? If you also do not make the API run in the cluster mode, it also doesn't help much, because otherwise only one is receiving the request at the same time, right? So in a typical production grade environment, you have a cluster API, and you also have to have a cluster fabric network. Okay. Now, question: is it possible? Because so far, as of today, Babisan, you have seen this one. Let me show you. You have seen a machine. So far, even in some of our test environment, you have seen only a very basic sample wherein everything is running on a single machine. Is it possible to actually deploy the fabric in a cluster environment? Question is, there are two types. We can use the cloud platform like IBM, Oracle, even AWS to set up our blockchain. But the problem is some of these are actually very expensive platform like Oracle. Question is it possible to actually create our own cluster fabric? The answer is yes. But first, Babisan, one of the demonstration today that I will be making, is it possible? Because normally when you deploy a cluster, you have to set up everything manually, right?
Mhm.
Is it possible to do the automation? So before I will demonstrate deploying a fabric in a cluster, can I demonstrate to you first how to make the automation?
Okay.
But would you like to continue the recording, or would you stop and then start another session, or just continue?
Maybe stop and the another
Start
session.
again. Okay.
Yeah.
So now I have demonstrated the API side. I'll stop the recording.